Hello everyone, this is Rithun from CKF, and today we'll be going over USACO 2019 US Open Contest, Bronze Problem 3, Cow Evolution. Let's first start off by reading the problem. It is the year 3019, and a surprising amount of bovine evolution has transpired in the past 1,000 years, resulting in cows with all sorts of interesting features. The bovine evolution record can be described as a tree, starting with a basic ancestral cow at the root with no special features. At each descendant level in the tree, either all the cows evolve a new feature, such as fire breathing, below where all cows with spots ended up with fire breathing, or there's a divergent split in the bovine population where some of the cows evolve a new feature, for example flying, and some do not. The leaves at the bottom of the tree indicate all the resulting subpopulations of cow in the year 3019. No leaves contain identical features. For example, subpopulation 1 contains cows with no features, while subpopulation 3 contains telepathic flying cows. Subpopulation 2, by contrast, has flying cows that are not telepathic. Subpopulation 3 is unique in its combination of flying and telepathic cows. An evolution tree like the one above is called proper if each new evolved feature originates in exactly one edge tree. For example, a tree would not be proper if spots evolved into being two separate branches. Given the description of the subpopulation of cow in the year 3019, please determine if these can be described as a proper evolutionary tree. Here's how the input format is. The first line of input contains the number of subpopulations. Each of the next n lines describe a subpopulation. The line starts with an integer k, and then k characterizes all the cows in that subpopulation. Characteristics are strings up to 20 lowercase characters. No two subpopulations have the exact same characteristics. Output format. Please output yes if it's possible to form evolution tree, explain the origin of the subpopulations, and no otherwise. Let's take a look at the first sample input. This sample input corresponds to this tree. As you can see, this starting number is the amount of end roots there'll be. As you can see, it's 1, 2, 3, and 4. This is the first branch. As you can see, there's spots and fire breathing. And this represents how many characteristics there'll be. 0 represents since there's nothing here, there'll be 0. 1 is for this one, going from here to here and here. Since there's only one characteristic, it'll be classified as 1. Next one, 2 telepathic flying. This refers to this branch. Now, instead of looking up how to solve the problem, let's work on how to find easier ways to simplify it. So instead of finding ways on how it works, let's find ways on how it doesn't work. For example, we have the starting cow, and then it evolves to have spots, and this one evolves to have flying. And if a tree wants a cow to have flying and spots, that would not be possible, because both of these would have to combine like this, and that doesn't work. Because if it goes to this branch, it has to be spots, but there'll be no flying. If it goes to this spot, it'll be flying, but there'll be no spots. So this way, it's not possible. So, when looking at the tree branch, we have to check if there's two things that we need, and if everything else behind it are the same, then it's perfectly fine. But if two things are not the same, then it doesn't work. For example, in this branch there's flying and nothing before it, and in this branch is flying and nothing before it. This works because both are the same for both branches. There's nothing before flying, even though both of them contain flying. So now, let's see how I did my code. First, I inputted array list. This is because we're going to be having different values and different size arrays. And scanner for the inputs. First, I got an input, created an input file, and took my input as int. This will be representing how many branches there are. Next, I created my nested array list. First, I tried to add in all the arrays. First, I went from 0 and went all the way until it is less than or equal to the roots. The first one will contain the next line, and if it equals 0, like this one, we're gonna have to skip because we don't want anything to do with that line since that line is perfectly fine. Next, we go on until we find a space and add in each value. So first we'll add spots and then we'll add fire breathing. And in the end, we add an array into tree because that's how the nested array lists work. After that, we set up our answer, and currently we set as yes because we're trying to find ways on how it will be no. So it always starts out as yes, and if we find something that makes it wrong, we change to no. We first try to loop through the array list. We get in the first value because in Java, the check always has to have a value. And if you say in this instance, what if size equals 0, then check will never be initialized. So we have to initialize it to first value. And k will always be initialized. So as we loop through the array, we get in the check value representing the value that we want to check. And next, we got the second value we want to check. And if both of these equal the same, now we have to check if everything before these two values are the same. First, we check if its placement is the same. If it is the same, then we skip over this part and go over here. If it's not the same, answer will equal no. Then we loop in through each ones before, and if it's exactly the same each time, the answer, if it is not exactly the same each time, the answer will equal no. And then after the entire loops, we output the answer. Thank you for listening to today's video, and we have this code and all of the code in previous videos in our backlogs. Thank you for listening, and see you next time.